Hello everyone. This video is to go over the tutorial 2 after you worked on it to show you the kind of solutions and the kind of answers you should have come up with. So if you remember, this is the tutorial file right here, and we learned a bunch of functions here. I first want to go over this part 2 here. So the demo, we have another video about this. The part 2 here, you should have worked on it in class and before watching this. If you remember, the idea is that you have this data set here of the number of different cancers occurring in the US on a given year. So we have the total population here, males, females, both combined. Notice that this is all cancer type combined, so I don't want to look at this. I'll just want to look at individual cancers. Here I have something that you didn't have to do, but just to make it easier to visualize these numbers, rather than having raw numbers, I expressed it here as a per thousand individual value. So it's hard to compare this with this because we don't have the same population of males and females, and so the rate here might be the same, but the numbers are different. Just it could be partly because we have a different population. So rate and obviously the both sex combined will be very different than these, just because we're looking at twice the amount of population. So here I simply have the values divided by the total population times 1,000, and this is not something you had to do. It's just to make my graphs easier to explain or to talk about. Okay, the next step here, really, once you have your numbers, and you don't have to do that, but once you have your numbers, you want to be able to have a mean, a standard error, something you can plot here. And so if you remember, to get there, to get those nice statistics, you would go in the data analysis option of data, and then you have the descriptive statistics. You would select here your input range. So if I select all types first here, and an output, I want my summary statistics, the output range, I select only sort of the top left corner of where I want my results. Let's say I want to put them here, click OK, and I have my numbers here. Okay, and this should be more or less the same as this. It is not, probably because I didn't take this. I probably took the first number here. I shouldn't have. But if I didn't take this first number, it should be the same results here. So I'm gonna. I don't want to keep that because I already had it here. Now notice when I get my different outputs, I reorganize them so they're nicely side by side. Here I have my three means side by side. I have the labels up here and the error bar side by side. There's no white cells in between those things. It's going to help me when I do the bar graph. So let's do a graph here. I want to show as a bar graph the means. So I select my labels and my means. In insert, I will select a type of chart. If you click here on recommended, you'll have something, or you can click one of the individual ones. In Windows, you have this easy access to more charts where you're able to select various types and see the results. Now I want my three values to be all the same colors, because I want them to be like one series, and it's going to make it easier after that to select the error bars for my three bars, and it's going to automatically put them in the right place. So this is what I want. I have it at the output here. Now remember, we need to put the error bars. So in Windows, you can access it from here. More options. In Mac, you don't have this little plus sign, so you have to go here. When you're in chart design, here you have add chart elements, error bars, more error bars, and so you have this this panel here that opens, format error bars. This little last icon here is where you can specify exactly what you want to see, and we'll want some custom value. All these other options are not appropriate options. They are very hard to get what you want out of them. So we do custom, and we're going to specify values. You have an error bar above the mean and below the mean. Most of the time it's the same. In fancy calculations, you could calculate error bars differently in the plus and minus range, but in this class it's always going to be the same. And so here the idea is that you want to select here the 3 entries that where I have my standard errors calculated. Here we're going to select the same thing, up and OK, and we have the error bars. Now you'll see my final results. I formatted all this, and we'll learn later on how to format things. Okay, now I delete because I have it somewhere else. I have it down here. But the next step is my histogram. So if you remember to create a nice histogram, don't use the default histogram options. We will want to use again that histogram options that's in the data analysis toolpack. And the first step is to create this bin sort of series so that I can determine exactly where each bin is going to fall, so that I have a nice representation. And one thing that can be useful is looking at, in my summary statistics, I have the minimum and maximum here for each of the things. Now we're going to use only the males and females combined, and so here minimum is close to 0, maximum is close to 1.3, and so the question is what kind of increment. I said as a rule of thumb you should have at least 10 bins, so it would be bins of maybe 0.1. I think that's initially what I started, and I ended up finding that I would want a better representation, like a finer representation, because if you use only 10 bins, I wasn't happy with the way this lower range looked. It would have worked, but just as a trial and error, I redid it with 0.05 bins, so twice the amount, 20 bins in my range roughly. And so to create that chart, you enter 0, 0.05, you select these two and drag it down up to at least the highest value, and you know what that is because it's 1.2. So actually I went too far here. Okay, I don't need that because I already have it. Once you have this, you will go back to your data analysis and histogram down here. You select the bin is what I just created here. It doesn't matter if it goes too far, it's going to be zeros and it's not going to show up, so that's okay. Input range is the actual cancer rates for my combined males females here, and let's say this time I want it as a new worksheet. Click OK, and I have my values here. If if I didn't select chart output, I could go back and create a chart out of this menu here. I would have something that would look more or less the same, but it created it for me. Now again, I will adjust the way it looks in a second, or I adjusted the way it looks, so I don't need to look at that. The result of all this is these two graphs here, where you'll notice I adjusted a lot of things, and what I show you here is above and beyond what we want at this point of the class. I added a figure legend. In the text I actually have the reference, and I have things formatted and all that, so that's more than what we need. What I do need though is some text that will sort of present your result a little bit, a few sentences of introductions and 1 or 2 sentences of result. And so what do I have here? First I have my hook here, and my hook, so remember, it shouldn't be trivial, but it should address the problem in a sort of broad way that is interesting, that will stimulate an interest. And so here I mentioned the fact that cancer is a major health concern, but there's something that it's the public does not always know the type of cancers that are prevalent. Okay, and so that's something that catches the attention, because like, oh yeah, hold on, I actually don't know which one are the most common cancers, or I might know some, but and so here I then have some statement that makes my argument, or that dwells a little bit on this general issue I mentioned. And so here, well, the prevalence of cancer will vary by country, or here I have geographical regions, and I cite something. So this is basically a point where you can show, well, I know I need to give background information, and I need it to be supported by primary research, and so this will support this sentence here. And then I have a sentence that sort of exposes or presents the problem I'm going to address specifically, and so quantitative identifies the gap in knowledge and exactly what I'm going to do. So quantitative information about the prevalence of blah 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 has not been summarized in recent years. So that's my gap in knowledge. Here in the US, we don't have a recent summary. I mean, that's probably not true, but the point of, if we were doing this research, it's because it would be needed. And so in this study, the incidence rates and identify a category that's relatively more common than others. Okay, results. So here I have a small sentence that talks about my first graph. Now these are averages. There's not that much we can do to. In theory, we would probably want to compare males and females maybe, or something like that. We didn't do these kind of stats yet, and so here I have very broad statement saying that, well, this average incidence is relatively low, which might or might not be true, but that at this point this is not really relevant. We just want to see if you can say something about the results that is that is related to what you're showing. Remember, you cite your figure, and here we just point out that some cancers are more common than others, and so that allows us to go on to this next panel, where I show this. So notice that here I've divided my bars in 2 colors that didn't come out like that. I just manipulated a little bit the graph to change the colors and put labels. Now again, that's above and beyond. Even without the colors and the labels, you could say a statement like this, where, well, looking at this graph, you notice something. You notice like a big clump here at relatively low incidence rate, and you have a few items here that have fairly, like, much larger incidence rate. So that's something that's interesting to mention and to focus on. And so here we can say there's 8. So these samples at the top here, they are relatively common. You don't see the bottom of my page. Do you not see the bottom of my page? Okay. Here, those bars here. So here the idea is that you say something like, well, we have 8 types of cancers that are relatively more common. And so again, I don't make a statistical, like an absolute statement, because we didn't do statistics to say this is more prevalent. It's just a sort of casual observation. And here I went even above and beyond and calculated the fact that these 8 samples represent 60% of all cancers. And so you can go in your table here. I identified the ones that have high cancer rate, and I just calculated here what proportion that represents, and it's about 60%. So this is it for this part here. I just want to show you quickly, in terms of practicing this second exercise here, it's really all the same tools. Okay, so I'm not gonna do in details that whole exercise. One thing I want to show you is searching on internet about how to create a Gaussian distribution that that's Gaussian with random numbers, not something that's uniformly distributed like the random function I showed you before. And so random normally distributed. Okay. And so here, generating random numbers with a normal distribution. A lot of things popping up here, and we have this function here, okay, norm_inv. You can look at the details. So here it asks, you can look at the norm_inv function, see what are the inputs to that. Here I have my random numbers, and you can see that this number here is going to be the mean, and this number here is going to be the standard deviation of the function, and it says it here, okay. And you can find other entries where you have another normal distribution. Well, you actually have different ways to do this here. Norm_inv. This is the easy function. Okay, so I copy that. I paste it here. I need to put an actual mean. We said 10 and 3, if I remember well from the file in there. Here, I'm gonna copy it again, and we said 11, right? So I have 2 series of numbers. I'm gonna bring it down a little bit to put a title, variable A, and here variable B. Okay, I copy and paste that. I don't remember, I said if I wanted, is it 1,000 numbers or something like that? Okay, 1,000 samples, but 1,001 because my first one is actually the labels. Okay, and then from there, we probably want to copy and paste special so that I don't have something that changes every time. Okay, so now you'll notice these are actual numbers, not formulas. And I can go again with in data analysis, create my descriptive statistics, create my histogram. Um, with the whole series, you should be able to see two nice Gaussian distributions with a mean close to 10, a mean close to 11, and a standard deviation close to 3. And if you redo the same thing with only the first 20 samples, you'll see that your distribution looks a lot less smooth because you have very few samples, and so it's going to be a poor approximation of your actual distribution. The mean also is going to be probably further from 10 than if you had the actual whole distribution. See, here I have 10.6 for variable b, 9.5, and so you have an estimate that is not really very precise. Okay, so this is all for this recording, and hopefully it clarifies the kind of things you wanted to come up with in this tutorial. Thank you.